Lesson 19 is on writing, evaluating, and finding equivalent expressions with rational numbers. And that probably sounds familiar because we just did that in Lesson 18. So we're just going to keep practicing it and we're going to kind of apply it maybe in some different ways. But I want us to get good at just working on manipulating the letters, not the letters, I'm sorry, manipulating expressions, because that's a really useful skill that's going to happen that you're going to need later on. Okay? So it says find the equivalent expressions from the list below. So when I look at this, we're just going to manipulate it. I always say the word manipulate it because we're not changing it. It's equivalent. It's the same. So one of the things I like to do is always change things to addition. This is already addition, leave it alone. But this x minus 6 here, I could go keep, change, change. And then I can rewrite this using my distributive property. So I can say 2x plus 2 times x is 2x, made it plus sign here, 2 times a negative 6, which is a negative 12. Now I can gather my like terms. Remember, I can't just go 2 plus negative 12 because these have x's and these don't. But I can add my x terms together. So if I have 2 x's and 2 more x's, that's 4x plus a negative 12. Now remember, adding a negative is the same thing as subtracting. So now let's look at this list down here. Do we see any of them that would be equivalent to this? Well, nope, because this is 12 minus 4x. So if I went keep, change, change, that would be 12 plus a negative 4. And this is a positive 4. Maybe right here, keep, change, change. And if I added my x terms together, I would get 4 plus 8 plus a negative 12 is a negative 4x. Nope. Maybe this one, if I use the distributive property, half of 8 is 4x. Keep, change, change. 8 times a negative 2. Nope, that's a negative 16. Okay. All right. See, we kind of keep going here. How about this one? Keep, change, change. Again, gathering my like terms. This ends up being 12, and then negative 6 plus 2 is a negative 4x. Nope, no negative 4s. Nope, that's not the same. How about here? Keep, change, change. Keep, change, change. If I have 1x and 2 x's, that's 3 x's. No. And then negative 2 plus negative 4 is a negative 6. Right here. This one seems to be the same, doesn't it? Okay, that one is the same as these here. Equivalent. Well, we might as well keep going, right? 4 times x is 4x plus 4 times a negative 4 is a negative 16. Keep, change, change. 3 times x is 3x. Oh, plus 3 times a negative 2, which is a negative 6. And finally, this is a tenth. We're going to talk about that later. A tenth of 40 is just 4. 4x. If I make that a negative 1/2, it would be plus half of 24 is 12, so a negative 12. Ooh, that one's also the same, isn't it? Okay, so we get a couple of them that are the same. Okay, well now that part's done. The next part should be easy. In fact, look at this right here. We just have 14x minus 16. Do we have any that are the same? Well, remember, we could go keep, change, change. Don't forget the second change here, right? Subtracting is the same thing as adding the opposite. And I see that right here. So I'll use a different color. Sorry, I get that. I can use different colors. Any of the other ones? Oh, right here. That was a 16 that was really scribbled, wasn't it? So this one was the same as well. All right, well then finally, how about this one here? Keep, change, change. I'm going to drop the parentheses because it's all adding. 2 times x and 2 times a negative 2, which is a negative 4. And if I have 1x here and 2 x's here, that's 3 x's. And if I have 2 and a negative 4, that ends up being a negative 2. So do I see any like that? No. This looked like it might be close because we have 3 parentheses 2x minus 2, or plus negative 2. But remember, if it's parentheses, then we have to distribute to both of them. Okay? So this unfortunately, has no matches because this isn't the same. Okay, so this is the type of equivalent equations we can write. Now we're going to switch gears a little bit, and I want to talk about money and discounts. We've done this before, okay? So we've got some percents here, right? And I want you to remember that the word percent means per, it's quotes there, per 100. Okay, per 100. So my original price, $100, $50, $20, it's 100% of it. Now we're getting a discount here of 20% off. We've talked about discounts a little bit. So I want you to remember that 20% means 20 per 100. 20 hundredths. And remember how we worked on change a fraction into a decimal? 20 hundredths would mean we could write 20 tenths hundredth spot, or 2 tenths. 20 hundredths or 2 tenths are the same. Okay, so let's use that. If I want to figure out how much my discount is, I will take my original price and I will multiply it by the 20%, 20 per 100. And if you grab a calculator and you go 100 times 0.20 or 0.2, it works out to be $20. But remember, that's not what we're paying, okay? We're paying 80% of it. So you take your original price of 100 and you subtract your discount, 20, and you pay $80. So remember, this is original, and this is the discount. We got to subtract it off. Okay? All right, so this expression, what this means, okay, is we're taking our original, our 100, and instead of writing minus 20, I'm going to write the expression here. I'm going to minus 100 times 0.20. Now just stick with me for this. I'm only going to write this a couple times, okay? These both have hundreds in it, so I'm going to divide them both by 100. Don't stress, okay? I just want to show you something. 100, I'm going to pull that out. It's like I'm factoring it like we do in our warm-ups. I'm pulling that out, right? And I'm getting 100 divided by 100 is 1, minus, I'm going to pull out this 100 divided by 100, and I'm left with just 20.20. Now, what is 1 minus 2 tenths or 20 hundredths, or however you want to say it? 1 minus 0.2 is 0.8 or 0.80, okay? Right here, if you're paying 80% of something, we can just take the 80% times 100. And if you go 100 times 80% or 80 hundredths, you get $80, which is the same as we got over here. Okay? Just stick with me. It's going to make more sense as we move on. Okay, so 50, same thing. I want 20% off. So I'm going to go 50 times 0.2, and that's 10. So this works out to be $10. So I'm going to discount the amount off is $10. If I take my original of 50 and I subtract 10, I get 40. Okay? If I write the expression, I could say 50 minus 50 times the 20% off, the discount, original minus discount, or I could just jump to this paying 80% of it and just think of it as, instead of thinking I'm taking 20% off, I can think I'm paying 80%. And I could just go 50 times 0.8. And guess what? You get $40. Okay. Let's just do 2 more. Okay, I'm going to do the 28 here. All right, so let's say, same thing. I'm going to take $28 times my discount of 20%, 20 per 100. And it's 5.6, which is $5.60. Okay, so my discount is $5.60. So if I wanted to figure out what I was paying, I'm going to take the original cost of $28 minus my discount of $5.60, and I get 22.4 or $22.40. Now, remember, I also, instead of thinking of it as taking 20% off, I could think that I'm paying 80%. So I could go $28 times 80% or 0.80 or just 0.8. And I get $22.40. So it's kind of like a shortcut way, okay? I'll tell you, it works with $14.50 too. We'll skip there, and I want to come down here to the X. Okay, so remember, this is just a number. We don't know what it is. So in all of these, we've taken the original price, in this case it's X, and we've multiplied it by the 20%. But remember, when we write a variable with a number, we usually put the number first. Okay, these mean the same thing. They're equivalent. Now, in this column, remember, we take our original and we subtract off our discount, which ends up being this. Okay? Or, remember, instead of thinking of it as original minus the discount, original minus the 20% of the cost, we could just think of this as the original times 80%. Sorry. Stop. Don't write that X there. Don't know why I wrote that X there. Just supposed to be 0.80. And as always, we put the number first. Okay? Real quick, this 80%, I want you to understand that if we have 100% of the price and we're taking away 20% of the price, that's where that 80% is coming from, okay? We're paying 80%. This is our original, paying 100% of the original. If you're taking off 20% of it, it means you're paying 80% of it. And this is going to help us figure out when we have like coupons and are getting discounts of something, what we're actually doing.